Good morning, everyone. In the last video, we have seen the data entry part of VAMR screen. In this video, we'll be discussing primarily the MIC guiding table. I've shown you in that video that we have an MIC guiding table option. So I have made some examples for you to understand the MIC guiding table. It will be a brief video. So as I've already told you in that this is the culture register page, and once we click on the sample number, it should pop up as various tabs. You all know. So I have made these few examples just to make you a little more familiar with how the MIC guiding table looks like. So the basic entry part I have done already. I'll directly go for the results. So these are the results for various. This is a Pseudomonas aeruginosa. I've manually added. I've selected the panel as 406 gram negative panel. These are the MIC values I have entered manually to create a interpretation. So I manually entered it and then clicked on the interpret breakpoint so that the interpretation takes place. The moment the interpretation takes place, what also happens is the MIC guiding table is created. So basically, what is an MIC guiding table? It is a representation of the test MIC as per the clinical breakpoints. As per the clinical breakpoints, primarily the susceptible breakpoint, which helps us to get a picture of how the breakpoint to MIC quotient or the MIC therapeutic index looks like, which and to decide on which drug is the can be the drug of choice considering other parameters into picture. The moment you will enter these MICs and click on the interpret breakpoint, the MIC guiding table will pop up here. Once you click on this MIC guiding table, how it would look like. So it will open as a pop-up tab. In the pop-up tab, how the MIC guiding table features. On the first column, we have the antibiotic list. It is color coded. The black ones are the first line antibiotics. Then the green ones, which are the second line antibiotics, and the red ones are the restricted or third line antibiotics. Then there are few color codes. As you can see, few colors. We have green color, we have yellow color, orange color, and some red color. So first I'll tell you how the MIC guiding table is made. What you do is all the susceptible breakpoints are aligned in the same line. All these susceptible breakpoints are aligned in the same line. So as you can see, we have S breakpoint, we have I breakpoint, and we have R breakpoints. So first, in the master, we enter the susceptible breakpoint, resistant breakpoint, and in between is the intermediate breakpoint. Then the MICs are entered. What is the range of MIC? What Vitek is going to test? Because we are primarily doing the antimicrobial susceptibility testing by Vitek. So, for example, for ceftazidime, the Vitek cards test the MIC from 0.12 microgram per ml to 64 microgram per ml. So, first is once the susceptible breakpoint and resistant breakpoint are set, aligned in the same line, on both the sides, the susceptible and the resistant ranges what it tests, range of MIC what it tests is displayed. So for those antibiotics where the Vitek changes or checks for a narrower range, like here in case of cefoperazone sulbactam, it checks only from 8 to 64. You can see a narrow range. For those antibiotics where it checks for a much wider range, the calling range of detection of MIC for Vitek is bigger. You can see a bigger range. So this is how MIC guiding table is created. How we enter the data. If you want to have a look on how we enter the data, I'll give you a view. So this is the antibiotic breakpoint. I'll just brief you how the data is, how the MIC guiding table comes, how we create it. So this is antibiotic breakpoint master. Suppose I want to enter for the group as enterobacterials using the 2022 breakpoints. So these are the various antibiotics with test. Okay, so amikacin, amoxiclav, these are the antibiotics, but with test we have what antibiotic is used for, need to be reported for what specimens, then what are the various susceptibility panels or Vitek cards for which these antibiotics should appear, the various breakpoints for this diffusion as well as the MIC, and what is the source. This we manually enter and every year we update it. So as you can see, we have records of all the past breakpoints and we keep on saving it. The new, we didn't delete the previous, we just update it on 1st of January, the new years, or as soon as the CLSI updates come, we update it here. Okay. So this is the master update, but I'm here to show you the how the MIC guiding table looks like. So as you can see, here is the MIC dilutions, how we feed it. So this is the master of an MIC guiding table, where as per the breakpoints available, as I've already told you, we have SIR. So we enter the susceptible breakpoint and resistant breakpoint and the intermediate ranges, MIC ranges here. And based on the Vitek panels, we go on either side, how, what is the calling range or what is the MIC range, what the Vitek cards test, we enter it on either side of susceptible and resistant range. This is how we manually enter for each breakpoint group and then we save it. So this is the master. So if the breakpoint changes, like recently for Piptas, so we went ahead and we updated the MIC guiding table Piptas in this page. Okay, from here. So this is the master, how we MIC guiding table, we create the MIC guiding table for it. Now going for the example, so it's very easy to see as I've shown you. The results I have already entered arbitrarily. Once I click on the MIC guiding table, it will open as a pop-up where you can see the susceptible breakpoint, the resistant breakpoint, and orange colored intermediate ranges, MIC ranges, and the boxes denote the test MIC. For a ceftazidime MIC of 16, the intermediate range is covered. The ciprofloxacin has the MIC of 2, which is blocked, the square is placed here. Similarly, cefepime has an MIC of 2, Piptas has an MIC of 8. What about these ones? The imipenem, meropenem, astronam. This is what we call as off-scale MIC or limiting dilutions. So Vitek includes MIC ranges testing from 0.25 to 16. So because the most susceptible MIC but Vitek test is 0.25, it cannot detect less than that. So the MIC range in those off-scale MIC comes as less than equal to 0.25. So here the therapeutic index has a little limitation because the further MIC could have been 0.12 or 0.06 or 0.03, that we don't know because the Vitek is not testing it subsequent dilutions. That is a limitation with any dilution method with the upscale MIC results. So this is how the result came. Based on these, you can choose on the drug of choices also. Like first we look for if any drug is feasible to be reported in the black ones or the first lines. So we have 2 drugs in the intermediate range, 2 in the resistant range. So we are not giving anything from this range. From the second lines, that is the green ones, we can see that amikacin box is here, cefepime is here, Piptas is here, and Magnix is here. So how the rule goes, the farther it is from the yellow line or the susceptible breakpoint, the farther the MIC is on the left side of the susceptible breakpoint, the more efficacious, the higher the breakpoint to MIC quotient, the more efficacious in vitro the drug is supposed to be. I repeat, in vitro. So we have to consider other parameters of the drug to be effective in vivo. That is, but in vitro effectiveness is more if it's further from the test MIC is further from the S. This concept is again what we call as breakpoint to MIC quotient. So as we'll recollect what is breakpoint to MIC quotient. So it is the susceptible breakpoint, like in case of CEFI, the susceptible breakpoint that is 8 divided by the test MIC, that is in this case is 2. So 8 divided by 2, so the breakpoint to MIC quotient is 4. For piptas, what is the breakpoint to MIC quotient? The susceptible breakpoint, that is 16 divided by the test MIC, that is 8, that is 2. So this gives a visual appeal of the breakpoint MIC quotient. The further it is, from 8, it is 1 dilution and 2 dilution against. 1 dilution is 2, another dilution is 4. So the breakpoint MIC quotient is 4. Here from 16, it is 2 dilution on the left side. So the therapeutic index or the breakpoint to MIC quotient is 2. Similarly here, 2, 4, 8. So for amikacin, the breakpoint to MIC quotient is 8. Why it is helpful for the clinicians? You can report it at the therapeutic index or the breakpoint to MIC quotient as a number 4, 2, 8. But for the clinician, it is little difficult to read the number and have a feel. Why the MIC getting table helps? Because it gives a visual picture. You only have to tell your clinicians, look for the higher drug and see where the boxes are. The farther it is from the yellow, the more chances that the drug is going to be efficacious. So in this case, amikacin is most farthest from the yellow, so it is going to be the best among the second line drugs. Okay, and whenever you report, you always follow the cascade reporting rules. If lower lines are susceptible, need not report the higher lines. Okay, so in this case, the second lines are quite susceptible. So in the clinical patient, we won't be reporting the restricted line. So this is how the MIC guiding table looks like. In our report, we usually write the comment below this MIC guiding table and give it along to the clinicians. Similarly, other MIC guiding table examples I have set. I open one more for you. So this MICs I have entered. Then I have clicked on the interpret breakpoint. So the interpretation happened. When I click on the MIC guiding table, a pop-up will open, which will display. As you can see, all the first lines are having resistant MICs. Then all the second lines are also having resistant MIC. Among the third lines, we have susceptible MICs. Among these, tigecycline and meropenem are having the same breakpoint to MIC quotient. Both are having 2 and 4 therapeutic index, 1 divided by 0.25, 2 divided by 0.5. But as tigecycline is not a very good septicemia drug or bloodstream infection drug, so in this case, we'll report it as meropenem as the drug of choice. So this is how a therapeutic index looks like. The only exception to therapeutic index rule is usually intermediate results we don't calculate therapeutic index for intermediate results. Okay, therapeutic index is calculated or breakpoint to MIC quotient is calculated only for susceptible result. The only exception to this is colistin, because colistin we don't have the susceptible result breakpoints. We only have intermediate breakpoints. That's why how we calculate the therapeutic index or breakpoint to MIC quotient is in the numerator we keep the highest intermediate dilution, that is 2 divided by whatever MIC we got. So in this case, 2 divided by 1 we have got. So the therapeutic index or breakpoint to MIC quotient is 2. 2 divided by 1 is 2. Suppose it is 0.5 as an MIC, then 2 divided by 0.5, 4. So this is the only exception where intermediate results is also used to calculate the breakpoint to MIC quotient. And in our page, you can anytime see the BMQ values calculated here. and the feel you can get through the MIC guiding table. So that's it for the presentation. In the subsequent videos, I'll be making video on how to go about the resistant phenotypes. As you can see, once I entered the results, it also interpreted the resistant phenotype. It also interpreted, it also found out the resistant. So how to go about, how to find out which resistant phenotype it belongs to, this I'll discuss in the subsequent video. Thank you for your patient listening.